Peatlands are amongst the most carbon-rich ecosystems on Earth and play a vital role in regulating water and supporting wildlife. Although they cover just 3% of the Earth's land surface, they store more carbon than all the world's forests combined. Peatland takes up 12% of the British Isles. When in a healthy state, they act as carbon sinks, regulate water tables, reduce flooding, and provide essential habitats for wildlife. However, around 80% of the UK's peatlands are dry and degraded. In this condition, they become emitters of carbon, and their other benefits are also greatly diminished. Re-wetting peatlands helps to lock in carbon, while contributing to the preservation of a healthy ecosystem, increasing biodiversity, and reducing flood risk to surrounding lower-lying land. Natural and man-made drainage features are a major cause of peatland degradation. By placing dams into these features, restoration teams can manage the peatland back to a healthy, wet state. Damming drainage features is an effective method of restoring peatland. The problem is that there is no centralized map showing man-made drainage features, naturally formed channels, or the locations of existing dams where restoration has taken place. Historically, mapping these features has been a manual, in-person field activity that is both costly and time-consuming, making large-scale mapping impractical. The AI4Peat project has harnessed artificial intelligence to identify these surface drainage features across England's uplands from aerial photography and LiDAR. Training AI models requires a substantial amount of labeled data so they can accurately identify the features of interest. Large volumes of digitized grips, gullies, hags and dams were used to train the models, along with LiDAR data, which was incorporated to enhance the visibility of features. The deep learning approach used is known as semantic segmentation. This method allows for precise detection of features in an image at the pixel level. Once trained, the model can accurately capture the shape, size, and boundaries of peatland drainage features. Object detection has been used to identify peatland dams on grips and gullies, outputting bounding boxes around these features. The trained model is run over millions of small image tiles. Using DEFRA's, Analytics, and Science Hub, which utilizes Microsoft Azure and Databricks, we process the tiles into a national map, providing a solution that saves time and supports the planning and execution of peatland restoration. AI4Peat's outputs will be published as part of Natural England's England Peat Map, due to launch in spring 2025.